All right, we made sound work. That's good.
Recording in progress.
Welcome, everybody. Okay, let's get this started. So today we're going to take a little detour from our story about lists to talk about testing. It's a little break while you guys are doing Mini Project 1, and we'll build some skills that you will get to explore on Mini Project 1. We'll get back to array lists on Friday. Okay, so when it comes to testing, I'm here to tell you this is like a major moment in terms of building your skills as a programmer. Whenever, some time ago, when I first started here, I was on like a panel where I had to interview the CTO of Pandora, the music app, which is very small in terms of importance compared to what it used to be. But we had an interesting conversation in front of a bunch of students, and one of the things that Pandora's CTO said is, a major skill they want out of people they hire is people who are test ready, who have this notion in their idea, this idea in their head about how to verify that your code actually works. So today, this is such an important thing that I have a little video here that I'm gonna explain to you a new way about how to be. So in this video, I'm gonna be Gene and you're gonna be Coop. Here we go. Oh, it's so quiet. I'm gonna need subtitles. You're ready to be taught the new way. Okay. Here we go. It's a training montage. Okay. So you're just watching me, and then you get the practice. It's very important. It's hard. Life's not easy. All right. Has anybody here seen the film Wet Hot American Summer? That was the one? Anybody? Ooh, you're missing out. I think it might be my favorite movie. I also like to ask this other question sometimes. Who here has seen The Big Lebowski? Okay, more people. Okay. But that was a shocker the first time I asked a bunch of students if they'd seen that, because that's like a transcendent film that lots of people get. Wet Hot American Summer, though. Oh, my God. Anyway, I had a very interesting experience, and I'm going to get to teaching soon, but I watched this movie with my dad when I was about 22, and it was like I'm a grown-up. We're both grown-ups now. We can talk about grown-up stuff. Anyway, all right. So this is the new way that we're going to be teaching you. And in particular, I want to reflect on how we know that our code works. The old way that you're used to is not so good. Probably in prior classes, you knew your code worked because there were some tests that you submitted to OKPy or whatever, or you ran tests that we gave you as part of the skeleton code. But in the real world, of course, you know that your code works because of tests you write yourself. Now, when I say yourself, it could also, of course, be a large language model. But the point is that there are some kind of programmatic constructs that are running your code and making sure that they have a reasonable input-output behavior. Now, I should note it's usually impossible to know that it definitely works. There's some limited research in this area, but it's not like a major thing. There aren't tools that are widely used in industry that are program verifiers. But in principle, you should be able to at least build some kind of input-output testing that's just going to work by trying out a bunch of inputs and making sure that the outputs are what you expect. So tests can provide strong evidence, but it's not going to be a foolproof proof, so to speak. So that's our new way. That's what we're going to try and do. All right? So to try out this new way of being, we need something to do. And rather than doing lists, I'm going to do a totally new thing, which is I'm going to talk about a sorting algorithm. So this will be more of what we do at the very last 4 weeks of class. But we're going to write a method that sorts arrays of strings. So for example, if I have an array of strings that's he is the Aguyatis of Mr. Conquis, when you sort this in alphabetical order, Aguyatis is first. Okay, that's what we're going to do. That's what we're going to build. Okay? So the old way, of course, is that you write some code, you give it to the autograder, it looks at your code in some way, and then it outputs some kind of grade scope results, and then you use those results in order to refine your code, or maybe you run the tests in IntelliJ. But this is definitely the sort of thing you've been used to in prior programming classes, and we've started giving you a flavor of the new way by giving you tests you can run on your own. So in this lecture, we're going to write sort, and we're also going to write test sort. So we're not going to rely on a test someone else made for us. And even weirder is we're actually going to write the testing routine first. That's going to be our goal, and then sort will come later. Okay. So what I'm going to do is give you a sense of what this will be like. Let me go to the A-list class. Why are you upset? Okay. All right. So I'm going to go in here. I'm going to make myself a new folder. I don't know what I was doing. Sorry, it won't compile unless I make it right. Okay, just ignore that. All right, so let me, because all of my lectures are all in one big project, and so if any of them doesn't work, then none of them will work. You might have seen that before. So I need a new, I don't know how to do it in the user interface. Okay, we're gonna go to the terminal. All right. Okay, let's make a new folder, X6 testing. Okay, in this folder, I'm going to make myself a new file, and this file will be called sort.java. And in this class, we are going to create a method, public static string, or public static void sort that takes an array of strings and sorts it. Okay, so sorts X in place. And right now, it's just going to return null, or do nothing. Okay. Then we're going to write the test that I mentioned. Okay, so I'm going to go here. I'm going to create a class, which will be called test sort. And I could have a main method, and I could do something like, well, I need to make an array. So let's do string array input. Okay, so give me some strings. Someone give me one. Velociraptor. That's long. Okay, sounds good. But it could be long. I think that looks close. I think that's right. What else? Iridium. What? Iridium? Sure. Okay, I heard iridium. That's not what you said. Iridium? I don't know. Okay, later you have to tell me what you actually meant. Horse. Okay, classic. 61B word. Yeah? Koshi? Koshi. Okay. I don't know what that is. Hopefully that's not like some sort of slur. He said it, not me. All right. And if we sort this thing, what do we expect it to look like? What's first? Iridium. Okay. Next. I got to do the alphabet real quick. H-I-J-K. Okay, horse. Koshi. Velociraptor. All right, am I happy with these? Is that enough stuff? Yeah, okay, some stuff happens. All right, now I want to verify that if I call sort and I say, hey, sort class, please sort the input, I now want to check that these two are equal. Now, how am I going to do that? I'm going to use a library that we're going to use throughout the class that will make this much easier. So before I get to that library, let me show you what it would look like if I tried to live code the rest. So if I were to do this, after calling, like we have input, expected, sort, after doing that, we would have to write some code that would be annoying. We'd have a for loop in which we'd say, okay, let's check each string, and are they equal? And if we're not, then we're going to say, hey, there was a mismatch at position I. We expected this, but we got that. And that would work, and you know how to do that, but it makes you tired. And who wants to do that? I just want the skeleton code test. Like, I don't want to do this stuff. So the good news is we're going to do a library which already does this pattern for us. That's very normal to compare two arrays, check if they're all equal, and then give useful output messages. And so someone has written, there are many such libraries, and the one we're going to use is called Truth, and it is made by Google. That's what we're going to do. So it's very tedious to write code like that, so we're going to use someone else's code that does this for us. Okay? Specifically, I am going to, what this framework is all about is so-called unit testing. And you can imagine that when you're writing programs, you're building a bunch of little abstractions. Like this abstraction we're building, what does it do? What's the abstraction? You give it an array in it. Sorts it, right? Other kinds of abstractions might be given an array and a couple of items in it, you swap them. Or given an array, find the biggest one, or whatever. These are all little abstractions. And each of those abstractions, you can also call it a unit. And what unit tests do is they verify that these individual units of source code actually work. Okay? Now, the unit testing frameworks that are out there, they save you the trouble of having to iterate over the array and generate your message. There's JUnit, which if you look at old 61B exams, for example, before Spring 23, I used JUnit, which is kind of a lower level testing library, which is fine. But then my master's student, Ethan Ordenlich, who is now teaching at Caltech, by the way, he introduced me to Truth and convinced me it was a better fit for 61B. And since then, we've been using this library, which is it's more fluent. It reads like English, as opposed to JUnit, which is a little messier. And also makes nicer messages. So this is a less tedious way of writing tests, even perhaps fun. And so I'm going to hop in and write my truth message, or my truth test. So I already did the beginning. And now all I got to do is say assert that, almost, assert that input is equal to expected. I think that's the right syntax. And now I need to do an import. And oopsie. Okay, wrong thing. Here we go. I got to set up. You guys have done this before. Project structure. Okay, libraries. Who's done this before? Hey. All right. Let's see. I don't think I have the library from this semester, but luckily it's the same this time around. Okay, so that should hopefully work. Okay, now that I've done that, it should import. Nope, wrong one again. It's an option on my computer. So I import that method, and then I run it, and I get back an error, hopefully. I will. I get back exception in thread. Expected iridium horse Cauchy velociraptor, but it was velociraptor iridium horse Cauchy, differs at index 0. And in fact, a lot of the error messages in our grader are just these error messages. We didn't have to write the loop that iterated over it. Okay, so that's what our test looks like. Any questions about this so far? Okay, so you'll get to do these. I mean, it's like not hard, and it feels good eventually. When you're used to it, this is amazing, okay? The example I give in the little textbook for our class is when you climb, like a large rock, you can climb with no safety equipment, and you'll get there faster, but if something goes wrong, then it will be worse for you. Maybe you will climb slower, or maybe you will not climb again. Similarly here, like you can write code without testing, but if you test, yes, it takes some time to set up, but it keeps you from running into trouble. So if you have ropes when you climb El Capitan, then you have a higher chance of making it. Maybe it's a little slower, but it's ultimately a better idea. Same deal here. Yeah?
Does insert that only work with arrays?
It'll work with basically anything. And one of the reasons I like it over JUnit is that it's just a fluid syntax that you don't have to say like array, assert array equals or something, right? So it's one common syntax for comparing basically everything. Yeah.
So the method you wrote was just a test?
Yeah, just the test so far. That's all I've done. Yeah. Then obviously the strings I came up with before are different than the iridium strings that you guys did. Okay. All right. Now, what we can do to make this even more like what you saw in the assignments, because you'll notice this is not what it looked like on the assignment. You didn't get this ugly red message at the bottom. You had this little bar on the side that showed you check marks. So how do we get that? Well, all I need to do is go up to this method, and we're going to rename it. So instead of it being the main method, I'm going to say public void, we'll call it test sort, and it doesn't take any arguments. I wasn't using this thing anyway. Args is not in there, so whatever. That's just something we won't really talk about in our class. So I do that. I got rid of the main method. Actually, you know what? No, I'm going to do it differently. Hold on. I think that's too much movement at once. Let's move all this to a separate function. Public void test sort. Okay, what does it do? It does all this stuff. And then I can call test sort. Okay. So I'm doing stepping stones here instead of too much at one time. So hopefully you all agree that this is the same thing, right? I just moved all the function, or all the functionality into this function. Okay, same deal. Oops, except I made it not static. Sorry. That will not work. Okay, oh, almost. Okay, so I've moved it into a function. Again, I'm moving towards what a normal test looks like. So if you want that nice like check marky thing, then what you do is rather than explicitly calling the function that's testing in your main method, you'll go up here and you'll add @test. Then you will remove the word static. And if you want, I can tell you why they made that decision, but testing methods have to be non-static. Then I need to import test. You should pick the one that has the word Jupyter in it. Both of these will technically work, but this one will behave better. And as Peyron and I were talking about, we should remove this from the library file that you have. This is out of date. It should be gone. But if you see both, you should pick the Jupyter version. This is the new version of this whole testing library. And at that point, I have a test, and I can delete my main. Okay. All right, and now I have this little arrow I can run, and then you see what you're used to from the assignments. I get an X because sorting isn't working, and I can look at that particular test. Before I take any questions, I will note, earlier I said your code has to have public static void main, otherwise it won't run. This one does not have that. Anyone want to guess how it works? I'll give you a hint. There is a main method. Yeah?
It runs in a separate file.
Yeah, it runs in some separate file we can't even see. So it's hidden from us. So it's a secret file. And what do you think that file does? So it's a main method that looks at this file and does what?
Call all the methods.
It iterates over all methods that have what? Test. So there's code, someone else's code, iterates over all methods and test sort that have this little test method attached to it, then compiles all the results, then IntelliJ reads them, and it looks nice. Someone else's main method. Okay, so that's really what's happening under the hood, but in the modern era, it's all hidden away from you when you use IntelliJ. Okay? But there is some main method, and there is code that has, I want you to give me all the functions that have @test attached to them, and that's what it does. So what does this thing mean? It's just an annotation. It has no syntactical effect. It's basically just like walking in and I just put like a red Post-it note on 7 of you, and then later someone comes and like sprays you in the face with, I don't know, silly string or pi or whatever. It's just a note for whoever comes later that you should be the one who is slimed. Okay? In this case, it's a note for the test runner, what should be run. All right, any questions about this whole little story? Okay. All right. Oh, I said no idea. I actually do know now. I figured it out today. Okay, cool. All right. So one added benefit to this, added benefit. Okay, what the heck? One added benefit to this whole process is that in addition to being a useful idea, like writing tests, it kind of gamifies the whole process. And you've had this experience working on the assignments probably, where you have these concrete mini goals, and you get a nice little pat on the back from IntelliJ when you get something right. You get a nice check mark, and you basically win the game once you have all the check marks. And I do this in my own projects. And when I worked at my friend's company a couple years ago, right before I did sabbatical, and a little bit during my sabbatical, when we were doing software engineering, these tests were really important to me. I wanted the check marks, and I would get them in 2 places. One was in my IDE, it was all in Python, and the other was in our CI/CD system. So we would push to GitHub, and then you would get all the tests running, and you get all the check marks when you would go look at the pull requests on GitHub. So this is a very common thing. And in fact, the first piece of industry code I wrote a couple years ago, 3 years ago, with this company, I started by writing the test and then succeeding at building the software that gave me a green check mark. So I'm very indoctrinated into this way of being. It feels right to me. And I'll try to convince you today of why it is so right. Okay, any questions as I proceed? So this is kind of all the little technical details. But yeah.
How do you test to make sure your tests are accurate?
Yes, your tests might be wrong. And in fact, if you watch the Spring 25 lecture, I had an error in the main test for sorting. And we caught it at the end because I got 2 alphabetical order things backwards. So sometimes you don't know. It could be the test that's wrong. And sometimes you guys email us and say, I think the autograder is wrong. But usually it's not. Yeah, it has been, but rarely because several thousand people try it. All right. So let's talk about selection sort. Why? Well, we need a sorting algorithm, and that's going to be the first sorting algorithm I teach you. Later in the class, we'll talk about many other sorting algorithms, but this is one of the simplest, and the most intuitive sorting algorithm, and it works like this, okay? If I want to sort a list of n items, like say these numbers, 6, 3, 7, 2, 8, and 1, one way I can sort them is find the smallest thing, and where should it go? At the front, obviously. It says so here, and also just makes intuitive sense. So we'll move it to the front. So I could take 1 and put it over here and slide everything over, but I'm going to do something a little strange, which is I'm actually going to take 1 and 6 and exchange them. So why do you think I did that? Like, it's not the only way, but yeah? Someone said something before I cut you off. I mean, it's true that 1 is less than 6, but why not just slide everything over and put 1? Like, swapping seems weird. Okay. So, oh yeah, go ahead.
It's much easier than just like sliding everything in an array.
Yeah, sliding everything over in an array is hard. Swapping is just one operation. I just take the 1 and the 6. If I were to actually take the 1 and like scoot everything over, unlike if I have like a stack of papers, like I can do it real fast, right? I take this paper, I moved it. But that's not how an array works. With an array, I'd actually have to move everything over, right? It would be like having these pieces of paper, and I have to like basically take this one over here, and I need to move this one over, and this one over, and this one over. That's basically what you would do in memory. Maybe you saw that, maybe you didn't. If you're at the correct angle, the visual is maybe helpful there. Okay, so let's keep going. What's the next smallest item? 2, and so where's that going to go? Who am I swapping with? 3, right. Okay, next 3 is the smallest. We're going to swap that with 7, and so forth. So basically every item, once it gets swapped into its place, we gray it out to say we're never touching that again, because nothing, we know this is all sorted. This is the smallest item. This is the second smallest item. This is the third smallest item. This is the fourth smallest item. Therefore, I never need to touch them again. Okay? You can prove that this is true or correct using invariance. We will not do that. Any questions about the selection sort algorithm? Okay, so we're going to write that code. So I'm going to try implementing this, and again, I'm going to make a couple mistakes on purpose that are in my brain, and hopefully I'll remember to do the right mistakes. And I want to basically demonstrate like a little bit of student style, what's sometimes called cowboy coding, where you just jump in and start writing code without a full design up front, and how testing can save you from trouble as you do that. Specifically, I'm going to show you how test-driven development, where we write our tests first, can help us avoid big problems. So I'm going to start by saying we need some functions. So I'm going to write a function called findSmallest. And the specific API I'm going to get, I'm going to copy it from here, findSmallest, okay, is going to look like this. So I need a method that's going to help me out. And I'm going to make it public. Maybe in a real sorting method I wouldn't, but I'm going to say public static void findSmallest string x. And I've already made a mistake, which is this thing should return a string. Okay, what's it supposed to do? Good question. For now, I'm just going to say return null. But I wanted to demonstrate test-driven development. I'm going to write the test first. Okay, that does two things for me. One, it gives me clarity about what I would like to do, because I have to actually think about an example. And then it also gives me a test I can run. So we have Velociraptor, Iridium, Horse, Koshi. Okay, and what is the expected smallest? Iridium, yes. I'm so curious what you actually said. And then I'm going to say assert that. Oh, sorry, I didn't call the function. I'll have actual smallest. It's going to be sort.findSmallest input. And then I'm going to assert that actual smallest is equal to, no, not is empty, is equal to expected smallest. Okay, we run this, actually run all the tests at the very top. And guess what? That one doesn't work either. Expected Iridium, but it was null. But now we have a little check mark that we can try and earn. There you go. All right, that's what we want. Okay, so let's try and do it. This is just a normal pattern that we've seen in Java before, or in a programming class before, which is we'll start by saying, I don't know, string smallest equals x0. That's one way to do it. And then I'll just say for int I equals 1, I less than x dot length, I plus equals 1. And then we look at each string, and we say, is it bigger? So we'll say if xi is smaller than smallest, then smallest should be xi, right? Okay, so we're going to look through anything smaller, then we return the smallest. Then we set the smallest. And then we return smallest, and we run into one problem, which is operator less than cannot be applied to string. Okay, so this is just a Java quirk. You can't compare strings with a less than sign. Java does not possess operator overloading. So when you have two reference types, you can't less than. There's no way, like in Python, you would write a function that looks like this, and it would tell you how less than is supposed to work. That doesn't exist in Java. So we have to do something else. What is that something else? Well, there's a couple ways we can figure it out. One of them is we can Google. So I'm going to say how compare strings Java. Okay. Let's see. Is this what I want? Maybe I want to say less than. Is this what I want? No, okay. I want how compare string, how less than strings Java. Okay. I'm going to find the most important stack. Ah, good. Stack Overflow post. How can I compare two strings in Java and define which of them is smaller than the other alphabetically? Okay. Let's do that. You can use string1 compare to string2. If string1 is lexicographically less than str2, a negative number will be returned, 0 if equal, or a positive number if string1 is greater. Okay, I'm just going to copy and paste that. I think I kind of get it. I'm a 61B student, so I'm just going to put that in my code. I'm going to say it's an integer. Okay, what was it though? It's smallest, or let's do xi compared to smallest. And what did it say? It said, if this thing is less, it's going to give me a negative number. Okay, so if comp is less than 0 for some reason, okay, this apparently means xi is smaller. and then we'll try to run our code. Now, what's nice about the test-driven development process is this is just some random Stack Overflow garbage. I don't know if it works. I don't even know if I read the post properly, but I can run this code, and it will give me some confidence, maybe, that it works fine. And indeed, it worked. So I got my check mark. Okay. Now, of course, you can also use a large language model, which is probably what you'll tend to do instead of Stack Overflow these days, because you're from this generation. So I don't know. We'll go to ChatGPT, and I'll hope there's nothing embarrassing on the side of it. Okay, that's going to hide that. I don't know what I'm talking about. Rats, probably. Our house is rats are visiting us, living in our house. It's not good. You can catch me after class. I'll show you rats in our kitchen. Oh, a rat in our kitchen who I've been tracking every night. I'll get him. Quick note, I don't know if this is responsible of me, but I don't like hurting things. So the 3 rats that I've caught so far, I've driven them to an undisclosed forest, and I've given them a starter pack, and I've given them some hints about how to live life. I told them, my wife was with me. She thought it was cute, but I said, good luck. You'll probably be eaten by a bird within a few hours or days, but at least you have a chance. So anyway, that's my attitude. Sorry. Rats, I mean, they're mammals. They're basically like you and me, in my opinion. That's how it goes. All right, anyway, what were we talking about? Rats. No. Give me an example of how to compare 2 strings in Java. Okay, you could do that. And maybe you get an answer, okay? Using .equals or compare to for ordering, okay? And we get an example, and we read it, and all right. Yeah, all right, that seems pretty readable. So that's good. What I do not recommend doing in this class, of course, is like pasting your function that's mostly done and saying, please write the rest, because then you're likely to miss whatever the important underlying lesson was. I think this is a great example, though. And again, I don't mind if you use this sort of thing to explore the Java language. When it comes to the big summative projects, I'll give more tips about how to not break the rules. But for now, this experimental semester on the homeworks and mini projects, I mean, I don't know. I'm just trusting you to do it reasonably. I had a wild thought earlier, which was I might do an opt-in project for like a small group of, I don't know, 10 or 12 people who on the last project just want to go totally hog wild with large language models from the beginning. And then we can maybe meet up and figure out what the right. Because I keep debating, like, should I teach in 61B how to use like fully agentic coding, like to take the automation slider and like do the most automated stuff? Because it doesn't feel like the right place in the curriculum, but maybe at the end it's like fun to do a little. So I don't know. I'll have more about this. I'm like constantly, every semester I say, let's do some more LLM stuff. So maybe I'm going to try and do a more structured thing for a small test group. I'll tell you the experiment from spring another day. Okay. So what we got here, we created test sort, then we created a sort function that did nothing. We wrote test find smallest, and then we created find smallest. Okay, so anyway, so as I noted, I used Google and a large language model to figure out how to compare strings. And as I note here, make sure you read what the LLM actually says if you're trying to build skills. Now, if you're just vibe coding like an app for your phone or whatever, like who cares? Like build it, and maybe you just make your cute thing and you don't really care how it works. Now, I should note that if you don't have strong fundamentals, where you run into trouble is you can have really subtle bugs or inefficiencies because you can't see the problems. This is extremely common. People have security holes in their code that they vibe code that just sticks API keys out there, and then they post it to GitHub, and you don't know what that means. You don't even know what an API key is, really, and you don't realize that you can like spend a lot of money by accident by having posted it because it's tied to your credit card, that sort of thing. There are also little subtle bugs or subtle inefficiencies in code that an LLM may make because it's not really thinking about efficiency necessarily. Okay, anyway, alrighty. Let's talk about swap. So the next thing we want to do is write a swap method. And again, I'm going to write test swap first. And so we're going to go do that. Okay, so we go to test sort, and we write swap, test swap. Public void test swap. Okay, what's this thing supposed to do? It's supposed to take an array. Let's take that same array over here. And we're going to, let's see, I'm going to double check what my right API is. AB, okay, we take 2 integers. So we're going to say swap input, sort.swap input. And which ones do you want to swap? Okay, sorry, sounds good. Velociraptor and Irradium. Seems fine to me. And then we're going to do string expected. Okay, if we swap those 2, then it should look like, I guess I'll copy and paste this whole thing. I don't know if that was faster. I'm going to misspell Velociraptor, so I'll definitely do that one. Horse Koshi. Okay, that's what we expect it to be, and then we'll say assert that expected is equal to input after we do the swap. This won't compile because we haven't actually created this method, so maybe I can say create method swap in sort. I'm so lazy. There you go. Actually, I'm going to call it A and B to match my slide, and I'm just going to return. Okay, we run test sort, and swap isn't working. Okay, no surprise, it doesn't do anything. So now we'll write swap. Okay, oh, sorry, gotta go to sort. Okay, so how do we swap two strings? What do you think we should do? Yeah, create a temporary. So we'll do input A. Why do we do that? So we don't overwrite it. And then I'll say input A equals input B. And input B equals temp. Okay. Now when I run it, hopefully it works fine. One thing that's nice about this test is, let's suppose you did the silly thing, which you might, where you just say input A equals input B, and input B equals input A. Like, you could do that. Maybe you make that mistake because you're sleepy or whatever. If you do that instead, if you made that mistake, oops, then you would get an error, like swap didn't work. And then you could use the debugger or look at your code and figure out what went wrong. Okay, so the power of the unit testing is you know you didn't make a silly mistake, or at least you didn't make a silly mistake that the test was capable of catching. Okay? Yeah.
What's the problem with writing the code first, then writing the test?
Either way is fine. You could do code first, then test. I'm just showcasing the idea of test first, then code. One advantage is that when you haven't written swap yet, then you have a little X, and you're like, I need my check mark. Yeah. It lets you basically verify that the test even makes some sense. Because if the test passes, probably a bad test, right? So imagine that my test was, I don't know, like we swap something with itself, then the test isn't useful. So I guess you could verify that the test is at least somewhat useful because a null implementation doesn't do any, or fails. Okay? Yeah. Is that a question? No. Okay. Let's talk about an error that we have. Okay. So we don't know. I didn't actually use the debugger to fix because I wanted to move slightly faster. Now that we have all the helper methods that we need, as well as the tests to give proof that they work, all we need to do is finish that sort method. Okay. So we're going to start by just doing the first swap as an exploration. And we're going to go in here. Let's see, one sec. Okay. So I'm going to go in here, and I'm going to think about my first swap. Okay, so wrong function. All right, so in the sort method, imagine we did string smallest equals find smallest x, and then we try to call swap. So we do x, and then we run into some trouble, which is swap takes what? An array and two integers. I need two integers, but I don't have two integers. I just have the smallest. Why did I do that? Because I was just like so excited to start programming that I wrote a method that found the smallest and gave me the string. So that's an error. Okay, what should this function actually return? The index of the smallest, right? So we should say returns the index of the smallest item. Okay, so that should be relatively easy to fix. We're going to put this aside for a moment. And now this is when I start doing surgery on my code rapidly, and why I really want my tests to be there to verify that things work correctly. So I'll say int smallest equals 0, for int I equals 1, I less than x dot length, and then we will do xi compared to x smallest. Maybe we'll call this smallest index to avoid confusion with the earlier note. Compare is less than 0, then smallest index equals I, and I'm going super fast. So there's a chance I messed it up. And how do I make sure I didn't mess it up when I was just speedily working on this? Yeah, go back to the test sort here. Okay, we got to fix our test method. Okay, actual smallest. What's the expected smallest going to be? 1. Actual smallest. And now we run this test again. Okay, that worked. I run all the tests. And I see that sort doesn't work, but find smallest, the new find smallest, does work. Okay? Point being, we had some issues here. We didn't realize we wrote the wrong find smallest. Once we realized we made the wrong find smallest, we were able to rapidly fix the find smallest and then test it. We had the wrong abstraction, but it was easy to test the new abstraction once we came up with it. Okay? Yeah. Right? Is this the normal life cycle? To start writing code and realize halfway through, I'm doing the wrong thing? Ideally, no. So with some expertise, you could rationally plan ahead and know what avenues make sense, what the architecture should look like. But chances are your architecture is not going to be good up front because it's hard to know all the right abstractions. I mean, in an ideal world, on project 3, project 5 and on project 4 this semester, you would sit down and you would write out all the methods and you'd make sure they all make sense and they talk to each other. But it's tiring to do that. Like, you just want to jump in and start programming because you're young, you're excited, you know, you just want to get going. Who wants to do all this planning? And this is a tension you see in all kinds of tradecraft, whether that's writing code or like installing shelves or whatever. Like, the more you plan ahead, the fewer times you have to cut. But sometimes it's worth it to just jump in and try. And this is a subject of much debate. People have different philosophies. People do different amounts of planning ahead. But what I will tell you is that this idea of unit testing is really useful either way you go. Okay? So I think the way I'm doing it here is probably not the right approach. I mean, I was being a little, you know, glib and aggressive in how I went straight into find smallest. Like, you'll note in the lecture, I didn't say, what should be the structure of the method? And some of you would have said, oh, we need, you know, an integer, because we have to swap later with integers. But I didn't give you a chance. I just was imagining someone jumping in. Because you will do this plenty of times in your life. That is, just jump in and start writing code. OK, we got one more thing to do, which is we need to write our sort method. OK, this is going to be kind of interesting. OK, so in our sort method, we want to do the following. OK, so we did like one little test swap just to feel it out. So usually what we would do, like, this would be the first swap. Like, that makes sense. But we don't, like, we need to, oh, sorry, there should be smallest index. OK, so that would be the first swap. And then we would want to continue on and do some kind of recursion. And I want to write recursively. You don't have to. You can write it iteratively, but I think it's fun to try and write it recursively. OK, so if I did something like this, right, I want to know what comes next. Okay, what's the recursive call going to look like? I'll let you think about this for 1 minute. Like, what could that possibly look like to say, just sort the rest? Go for it and think. It's an impossible question, though, so good luck.
Yeah, you would need the.
Okay.
Yeah, I don't know. My boss was definitely getting worse. It's like I'm sitting on a slot.
All right. Any thoughts? I mean, I said it was an impossible question, but anybody have like a texture of something they want to do? Yeah?
I mean, I know this statement said don't change the parameters, but I'd like to change the parameters
Oh, you want to change the parameters here? Yeah? OK.
so that you can like include what part of the array you want.
Right. You could give some other extra parameter to say where you should start. Although that's a little awkward because then that means whoever's trying to sort needs to do that too. Okay, but there's a very similar, there's like a way to avoid this problem. I should note that like some of you may, you know, have Python brain and been thinking like, can I do like that somehow? Like that would be cool. And then have a base case, but that's unfortunately not possible in Java. Like that would be cool with a base case. But Java doesn't let you do this. Like it doesn't have that nice ability to basically sub-array the array. Okay, so we can hack a recursive solution using what you suggested, which is having another parameter. But rather than changing this sort function, which is the world's, everyone's going to use sort. We don't want the user to have to like tell me more stuff than just their array. So we're going to make a private little helper method here that you've seen this trick before, which is I have a recursive helper method. Okay, I'll put it below, I guess. Recursive helper method. Okay, it's going to be called sort also. But it's going to be a little different, OK? What do we need? Like, what's the thing you wanted?
Like what the smallest
Yeah, right. So we'll call this start. Okay, so it's a recursive helper method that sorts x starting from position start. So for example, if I want to sort the entire array, what would I do?
X, 0.
Yeah, sort x comma 0. Okay, so up here, sort x comma 0. That will call this function. Okay, private static void sort. Okay. So this says sort the entire array, because right here it says sort the array x starting from position start. If you start from position 0, that's the whole array. Then what we'll do is the following. Smallest index equals find smallest x. Then we'll do swap, start, smallest index. And then we will do what next? Sort x, start plus 1. Okay. Anything else I'm missing? A base case. Yeah, well, let's try running it, see what happens. Okay, it gets upset. It goes out of bounds. If you ever see something like that, you're probably missing a base case. Okay, so what should it be? Also, recursive code can be hard. Do we know it works? I don't know. That's what the test is for. But when do we want to stop? Maybe. Let's try it out. Okay, so we got an array. I like to do a small example, A, B, C, D. Okay. Stop when what? Start is 0, 1, 2, or 3? 3, right. Okay, so what's the length? 4. So yes, I agree. If start is length minus 1, then we'll just return. That should be fine based on this little example. Am I totally sure? No. But let's try running the test and see what happens. Okay, let's find out. All right. Oh, we still have a bug somewhere. Okay. So we expected iridium, horse, Cauchy, velociraptor, velociraptor, horse, iridium, Cauchy. Okay, that's a little weird. So we have some kind of bug, and we don't know what it is exactly, but we were feeling pretty good. We were going to push play, and it was just going to work because everything just felt that way. Like that was the feeling in the air, right? It was like that note in K-pop Demon Hunters in Golden, the high one. But something went wrong. I'm going to try and work that in every time. But actually, maybe every Friday I'll do a really dated reference, and I'll try and work my way back in time so that by the end of the semester we're talking about Buster Keaton and stuff. So Monday, Wednesday will be the K-pop Demon Hunters reference. Friday will be a series of increasingly antiquated things. And then Payron, I don't know what your plan is for lectures, but you'll have to start thinking about that soon probably. Okay, so we tried implementing this, but we ran into another design error. Okay? So what do we know? We know that the helper methods, they probably work. We feel pretty good that swap works and find smallest works. And sort, it's supposed to be simple. I mean, it's just like, okay, find the smallest thing, swap it, do the rest. I mean, maybe something's wrong with the recursion because I don't have the brain necessary to understand this mysterious technique. But there's something a little more fundamental. It's not that we messed up the recursion exactly, but it's something a little wild. Okay? So let's try to use the debugger as seen in, oh gosh, hold on. As seen in homework 4 and 6. Is that right? It was 4 where we started it? 4. Okay, thank you. Okay. So what I'm going to do is I want to find where reality diverges from expectation. This is such an important skill. This is like science fair experiment. You expect something to happen. You have a hypothesis. You're watching reality unfurl, and at some point it's not doing what you expect, and this is exciting. It's new physics. It's, penicillin. Something strange is happening. So how do we do that? Well, being a more expert debugger, I'm going to say I want to look at every swap. I'm going to set the breakpoint there because I think that's where, it's like an actual unit of abstraction to look at. I'm going to run my code until we do my first swap. I'm going to see what happens, and I'm going to repeat that process until something weird happens. So I run my code again. I get to this point. Okay, we're running test swap. And here's what the visualizer tells me. We have iridium, horse, Cauchy, velociraptor. That's the expected. Okay, we don't care about that. We want to look at the input. So we have velociraptor, iridium, horse, Cauchy. In selection sort, what's the first swap supposed to be? Iridium and velociraptor. Okay, let's see if that happens. It did. Awesome. Great. So does that match our expectations? Absolutely. What will be the next swap? I'm going to push this button, resume program. That will take me to the next swap. We're just about to do the second swap. What should be the next swap? So we have iridium, which should not change, velociraptor, horse, Cauchy. Horse should swap with velociraptor, okay? Oh, no, that's not what happened at all. Ugh, that's bad. Okay, that what I just showed you at the end of the lecture, unfortunately, when you might have been drifting a little in attention, is the most important thing. I conducted a scientific experiment. I had a very clear sense in my head it should be doing exactly this, and then I saw it did not do that thing, and this is extremely bad. Okay, the second swap is not supposed to be this. Let's try it again. So I want to understand now, why did that happen? Okay, I have enough state in my head to remember it wasn't the first swap that was broken, it was the second one, so we'll go ahead. And this time, before I do the second swap, I'm going to look at the state of the universe. So I have x, start, and smallest index. I can scroll over here to say what the answers are, or I guess I can go down here, either way. And I can see that the swap that's about to happen is the following. We are trying to swap start, which is 1. Does that make sense? Is that the right thing to be swapping? Yeah, we should be moving Velociraptor, and what should be the smallest thing? 2, but it's not. What is it? 0. Is this the smallest index? The radian? Yeah, in some sense, technically, yeah. But what's the problem? We're only supposed to look at everything over here. This is supposed to be grayed out, but we were looking at the whole array. Okay? So our find smallest method worked perfectly, but it was the wrong find smallest method. What needs to happen? What do we need to change about our find smallest method so that when we're trying to do this swap, we don't consider the 0? What do you think? Give it a start index. We messed up big time, again. But using the scientific process, this is the interesting version of finding a bug. It is much more interesting than asking a TA like, and then they give you hints. Or you ask a large language model, it's like, you dummy, your function's wrong. The process, that idea, even though a large language model will probably spot this, I haven't tried it, that idea of being able to have a hypothesis, find the problem, understand it, and then fix it is super important, because in much larger programs that are not just this little simple example, an LLM may be totally useless. It may be just a massive code base where you need to be able to understand the state in some high level of abstraction and fix it. So how do we fix it? We're going to add in int start, and we're going to say smallest item that is still active, i.e. at start or later. Okay? If you are someone whose attention drifted, I implore you to please watch like the last 10 minutes again. You can 2x me, because this is super important. Okay. Find smallest. Okay, let's change it. What start index do you want? 0. I don't like 0. I think 0 is, oh, you can't put start because that's not a variable declared here. I think 0 is the wrong choice. Why? Because we already know it works, right? Like 0 was that was the default behavior. It looked at the whole thing. So give me a different start. 2. Okay, if it's 2, what's the expected smallest between horse and Cauchy? H-I-J-K. 2. Okay, so it still should be 2. And we run it again. So, got to change my thing here. Smallest index starting from what? Start? Okay. So we run that test again. Yeah, sure. And find smallest didn't work. Okay, hold on. Oh, right. We gave it a new parameter, but we didn't use it. That was an honest error. Okay. Start is unused. So where do we need to do? What do we change? Which line number? 24. This should be start. Okay, we run this, and we get still wrong. Okay, hold on. Why didn't that work? Oh, the for loop. Oh, aha, another bug. Okay, great. Where should it start? Start plus 1. Okay, run it again. And we finally got it. This is why unit testing is so important. I was trying to get through lecture quickly, right? I mean, not that I'm super out of time, close. But I got the answer, and I knew it was right, even though I was making 2 stupid mistakes in a row. We finally run the final whole thing, and I think it should work now, hopefully. Yeah, there you go. So we wrote a sort method. Great. OK, so let me just summarize the process. We had a series of like iterative design changes, and testing really made a big deal. So this is basically the whole thing. Testing gives you stability and scaffolding, incredibly important. Like, I wasn't worried that swap was broken or that find smallest had a bug in it because I had tests for them. Turns out they were the wrong find smallest and swap, but we fixed them later. Okay? So I have one extra. I'm not going to talk about it in class. This is an online-only video. But I have some testing philosophy if you want like 8 more minutes about the philosophy of testing. That's all. See you Friday.
Recording stopped.